Alright, here we are still looking at problems on angles of elevation and angles of depression. So we are solving questions on this topic of angles of elevation and angles of depression, and this is problem 3 or question 3. Let me read what the question says so that we can know what you want to do. The question says the diagram below represents the vertical cross-section of a mountain with height NQ standing on the horizontal ground PRN. If the angles of elevation of the top Q of the mountain from P and Q are 30 degrees and 70 degrees respectively, and PR equals 500 meters. Calculate correct to 3 significant figures: Roman figure 1, QP, and Roman figure 2, the height of the mountain. Alright, so this is the diagram that the question is referring to. So here we have the height of the mountain as NQ, that is the height of the mountain. So I'm representing the height of the mountain with small letter h. And then in the same question, we are told that this height is standing on the horizontal ground PRN. Horizontal ground PRN, and then we are told that the angles of elevation of top Q of the mountain from P and from P and R, not Q, from P and R, sorry. So from P and R, so this is angle of elevation from P and R are 30 degrees. So the angle of elevation from P is 30 degrees, and from the angle of elevation of point Q from R is 70 degrees. Then we are told that distance PR is 500 meters. That is distance from here to here is 500 meters. Distance from here to here is 500 meters. So the question now says we should calculate correct to 3 singular figures: QP, that is distance from here to here, and then the height of the mountain, that is distance from here to here. So if you look at this figure that we have here, we have two right angle triangles. We have two right angle triangles. We have right angle triangle PQN and right angle triangle RQN. Alright, so we know the distance from point P to point R from here to here is 500. So what is now the distance from R to N? That is not given in the question. So what I have done here is that I have represented the distance Rn with letter X. So meaning that the total distance from here to here, that is from P to N, is X plus 500 meters in brackets. So take note of that. Now, because of the space, I believe you have this question in mind. So I'm going to rub this off so that I can have enough space to solve the problem. Okay, now don't forget what you want to do. So we are to calculate the length QP and the height of the mountain, that is NQ. So that is what we want to do. Now, the first thing I'm going to do is to determine the value of the height of the mountain. That's the first thing I'm going to do. I want to determine the value of the height NQ or H here. Now, I need to break this whole figure, I need to break it down into two. As I said that we have two right angle triangles. We have right angle triangle PQN and right angle triangle RQN. So I'm going to break them down. So both of them, they have common height. This height is common to these two right angle triangles. So I'm going to break them down. So I'm going to start with right angle triangle RQN. So for triangle RQN, So, and in this case, we are going to make use of our SOHCAHTOA. So that is SOH and CAH and TOA. So I believe you know what I mean by this. So if I'm to work on right angle triangle RQN, this is the height. This is the height. The height is what we are looking for. So we assume that it is given, and then I have this RN, which is the adjacent. So, and then I have this included angle. So which one among these are we going to use? So we are making use of this one because we have the opposite as H and we have the adjacent as X. So, and then we have the angle. So in this case we have tan 70 degree to be equal to opposite, that is H here, over adjacent, that is X. So then we cross multiply. So if we cross multiply, so we have H to be equal to X tan 70 degree. So this is my Roman figure 1. So this is equation 1. This is equation 1. So now for triangle PQN or triangle PQN, so this is still the opposite, but for the adjacent is distance from here to here, distance PN, so which is the summation of distance 500 here, that is PR and RN, and here we have the whole of PN to be X plus 500. So we still have this height, so the height is common to both of them. So here we have tan 30 degree. So the angle we are using now is 30 degree. So tan 30 degree, so is equal to H over X over X plus 500. So here we have, so let me come here. So here we have H to be equal to bracket X plus 500, so tan 30 degree. So don't forget what I said. So this is equation 2. So don't forget what I said, that this height H is common to both of them. So therefore, we equate 1 and 2. So equate 1 and 2. So we equate equation 1 and equation 2. So equation 1. So we have X tan 70 degree. So it's equal to equation 2. We have bracket X plus 500 tan 30 degree. So the first thing that we need to do here is to determine the value of X. So to determine the value of X, I'm going to divide both sides by tan 30 degree first. So here we have X tan 70 degree over tan 30 degree. So it's equal to bracket X. So it's equal to bracket X plus 500 bracket tan 30 degree. So all over tan 30 degree. So this will cancel this. So then, so what we have here, so we have this to be X tan 70 degree over tan 30 degree. So which is equal to X plus 500. So here we find the value of tan 70 and tan 30 degree. So this will give me, so this is 2.7, tan 70 is 2.7475, and tan 30 is 0.5774. So which is equal to X plus 500. So I will divide, this is X, this has X, this X is here. So if I divide this by 2.7475 by 0.5774, so this will give me 4 points. So here we have it to be, so this will give 4.75842x. So it's equal to x plus 500. All right. So because of space, I need to run this off. Okay. So here now we collect the like terms, we bring this here for us to determine the value of x. So we now have 4.7584x minus x. So it's equal to, so what I will have, that bring this x to this side, what I will have left here is 500. So here I have 500. So this is 500. And this will give me 3.7584x. So it's equal to 500. So it's equal to 500. So then I will divide both sides by 3.7584. So this is divided by 3.7584. So it's 4. So this cancel this. So x is now equal to, let me use another marker. So x is now equal to, so 133.003. So x is approximately, or x is equal to 133 meters. So if x is 133 meters, I can go on and determine the value of h. So from equation 1, so we have h to be equal to x tan 70 degree, and this is equal to, so this x is 133, so here we have 133 times 70 is 2.7475. So x is equal to, h is equal to, so this gives us 365. So this is 365 meters. So therefore, so the height of the mountain, that is NQ, so is equal to 365, or QN. I think it is QN in the question. So QN is equal to 365 meters, which is the height of the mountain. All right, so this is the solution to Roman figure. Okay, so Roman figure 2. So we answered Roman figure 2 before Roman figure 1. So the height of the mountain, QN, is 365 meters. Now let's go and determine the value of QP. So QP. So to do that, so for us to get the value of QP, so we know that the distance of PN now will be 633 meters. Why? X is 133. So 133 plus 500 will give us 633 meters. So we have the adjacent, and here we have this to be 365 meters. All right. So there are about 2 or 3 ways that I can use to find the value of QP, but what I'm going to use is that I will still make use of trig ratio. So here I want to have the hypotenuse and I have adjacent. Hypotenuse and adjacent. So in this case, I'm going to make use of CAR. So as I said here, that we have this to be so CAR 2. So here I have adjacent, and I want to look for hypotenuse, which is QP. So I'm making use of this angle now. I'm making use of this angle 30 degree. So here we have cos 30 degree to be equal to, so adjacent is 633 over hypotenuse. So hypotenuse is QP. Okay, so I can write this as QP to be equal to 633 over cos 30 degree. So this is equal to 633 divided by cos 30 degree is 0.8660, and this will give us, so this is 730.9. So QP 730.9, and we are told that our answer should be related to 3 significant figures, and this will be 731 meters. So this is the solution to the question. So I believe this is clear to you from the beginning to the end. So I really appreciate you. Thank you.